Okay, this is a tutorial on how to cross-compile for an embedded device. So on the right here, I have my Raspberry Pi. On the left, I'm on my host machine. And let's say we're compiling this simple program here that it's hello world. Let's say we compile our code. So we've just created hello app1. We're going to copy it over to the Pi. You can see it's here now, and if I run it, it won't work. However, if I copy the source file over, we use the compiler that's on the Pi itself. And you can even see that actually that took longer. So that was like a whole second, whereas on our computer, one was like right away. Whereas on the Pi, one Mississippi 2, Mississippi 3, Mississippi. That was almost 3 seconds. Okay. So that's also part of the reason why you want to cross compile, but we'll see here that okay. So that one worked that we just built, but the one that we built in our host machine did not. And that's because the one on the host machine, whoops, was if we inspect the file with this command called file, I can just not be hasty and okay, so it's for the x86 architecture, which is most Windows laptops, for example, that you'll be working on. Not Windows, but just most chips on a PC. And if we do hello to the one that we just built, it was compiled for ARM. So that's kind of the fundamental problem, is that we may not be able to build right on our Raspberry Pi, but you have this incompatibility with the G++ on your host machine, and you'll notice that it actually, not only will you have different versions, so here on the Raspberry Pi we have version 12.2, but also note that this specifies the type of compiler it is. So see how this is Ubuntu 11.4, however this is for Raspbian OS. In this context, the question is, what do you do? There's a few ways to do it. In some cases, you can build it right into the image that you flashed onto your Pi. But I'm going to show one way, which is you go to the ARM website and you have all these tool chains that you can choose from. And you find the case that applies to you, which is we're on Linux. So we're on Linux, and this is our host architecture. And our target is an Arm32-bit, which you'll have to figure out by looking at your data sheets and on the documentation that with your Pi. And then notice that you might just try and download the latest one, but it will usually be safer to download one that's related to the version that's on your Pi. So in this case, I'm going to download it here. So this is the latest version. That's actually not what we want. We want 12.2. So 12.2. I already downloaded it here. And you'll notice in this binary folder, these are where the actual compilers are. So we have G++ and GCC. So here's the compilers we need to use. And if you search cross-compiling toolchains in the CMake documentation, you'll get this page here. And you can usually specify this as a file, but I'm just going to put it right in the same CMake lists for our example. So what's our system? If you, again, look up the CMake documentation, the closest equivalent I found was Linux. So I'm just going to say Linux. The compiler, this is relative to if it's on your path or not. So, right, in any case, I'm just going to specify a path. So copy path, this is our C compiler. Path, this is our C++ compiler. It's the same idea for the root path. And then we have to say that this is related to making sure that it doesn't use our host programs. And similarly, to make sure that it uses the library and include directories of our environment, which will become important when we try to build the full app. And then I've put these prints just to show what these environment variables are set to. So just going to start over. Build. See, the sysroot still isn't defined, but our compiler is now pointing to what's in the environment. Now do make build target hello. And if we inspect the shared object we just made, you can see it's now for 32-bit ARM, which is what we want. So we'll do the same thing for our app. Submit lists. I believe we're going to have trouble now with our shared object. Copy path. Okay, so as expected, the file is not recognized. It's bad practice to install it to our host system, but for this example, why not? This is our ARM one, and just do make install. Okay, so this, because it says installing and not up to date, that means it did move the new version that's ARM to that location. So if we go back to here, so now it built. And we'll inspect it. We can see that it's made for ARM 32-bit. And because this is a manual example, we're now going to copy it over to our Pi. So copy. Okay, so this is now on the Raspberry Pi. This is the ARM version we just made. I think it might work actually because the library is there from before. Yeah, so here, so it works. But note that do LDD. That's because I copied this over before. So you would also have to copy over the shared object that you made for ARM as well, or it would complain it couldn't find it. And that's all I wanted to show for this tutorial. Thanks for watching.